Hey guys, today we are going to finish up our lesson on natural log and base E by doing some real-world examples. As we talked about in the first video, natural log and E are used in banking, and here's how. This formula, A equals P times E to the RT power, is used for compound interest. P is the amount you started with, that's the principal. R is the interest rate, and it is to be written in a decimal. T is the time that the money is in the account, and A is how much money you will be left with in the end. Okay, so suppose you deposit $1,000 in a banking account, paying 5% interest compounded continuously. What is the balance after 10 years? Okay, so let's write out each variable. A, that's the ending balance. We don't know that. P, that's the principal. That's the amount we start with. That's $1,000. The next thing is E. Remember, E is not a variable. E is a number. R is the interest rate, 5%, so 0.05. And T is the amount of time, and that is 10 years. Okay, so A equals P, the principal, $1,000, times E to the R, which is 0.05, times T, which is 10. Okay, now in this equation, there's really nothing that needs to move from one side to the other. We can actually just type in the right side into our equation. So that's 1,000 times E to the 0.05 times 10 power. Okay, so we get 1648.721271, but remember, this is dollars and cents. What we need is two decimal places. So it's in dollars, $1,648.72. How long will it take to grow the account to $1,500? So now the ending amount, that balance at the end, is going to be $1,500. So $1,500 equals the principal. What we started off with was $1,000 times E to the R, which is 0.05, times T. How long means we don't know T, so times T. Okay, so we're going to divide both sides by 1,000. 1,500 divided by 1,000 is 1.5, so we've got 1.5, or it could be listed as 3/2, either way is okay, times, or equals, E to the 0.05 times T power. Okay, now we want to get E out of here so we can solve for T. We're going to do natural log on both sides to cancel out that E. So we get natural log 1.5 equals 0.05 times T. And then we will divide both sides by 0.05. Okay, so we need to put in the calculator natural log 1.5 divided by 0.05. Okay, so 8.1093 years. So just a little bit over 8 years, it'll grow to $1,500. Okay, suppose you deposit $700 into an account at 6% interest, compounded continuously. What is the balance after 8 years? So what is the balance? That's A. We want to know A. So A equals P, the beginning amount is $700, times E to the R, 0.06, times T, which is 8 years. Okay, so this is another one we can just type into the calculator. 700 times E to the 0.06 times 8 power. Okay, so that's $1,131.25. how long will it take you to have $2,000 in the account? So that ending balance is now $2,000. Okay, so that's going to equal the beginning balance, 700, times e to the r times t power, so that's 0.06 times t. Okay, so how long? That's the amount of time. So that's why our variable is t. So we will divide by 700. Okay, this time let's leave it as a fraction. So we'll do 2,000 divided by 700, and then math, enter, 20 over 7. Or we could easily just have canceled out a couple zeros and get 20 over 7 that way. So 20 over 7 equals e to the 0.06 t power. Natural log both sides. So we get natural log 20 over 7 equals 0.06 times t. And then we'll divide by 0.06. So we get natural log 20 over 7 divided by 0.06. And we get 17.4970 years. Okay, the only variable that we did not solve for at this point is p. So let's add a little something to this last set and say that we want $2,000 after 10 years. How much money should we have started with? So now we're not going to deposit $700. We're going to have to find out how much to deposit. So if we want $2,000 to be the ending balance, we want to know how much to deposit times e to the 0.06, and we said after 10 years. Okay, so this is going to tell us how much money to deposit so that we have $2,000 after 10 years at a 6% interest rate. And we can solve this in one step by dividing by e to the 0.06 times 10 power. So 2,000 divided by e to the 0.06 times 10 power. And it looks like we're going to need to deposit $1,097.62 in order to have $2,000 after 10 years at a 6% interest rate.